we are going to go over the last type of transformation today, which is a rotation. So a rotation rotates or spins a figure around a fixed point, usually around the origin. And the origin, remember, is the center of the graph at 0, 0. So this would be our origin. The direction of the rotation is described using clockwise, which remember is this movement, so always think about how a clock operates, how it turns, or counterclockwise, which is just the opposite. So that would be going this way. As well as degrees. So we use clockwise and counterclockwise to tell us the direction, and then we use degrees to tell us how much of a direction. 90 degrees is 1 quadrant, 180 is 2 quadrants, 270 is 3 quadrants, and 360 is 4 quadrants, or a full rotation. So our first step for rotating this figure 90 degrees clockwise, so I'm just going to put an arrow to myself, which means to spin my paper that way. If I'm going to spin the paper in the correct direction and the correct degrees, that means I'm going to spin 1 quadrant in that direction. So that means I will take my paper and spin it 1 time. So my second step, which I'm going to read sideways, which is a little weird, is to label each vertex, which is the point of the image. So G is a vertex, T is a vertex, and B is a vertex, according to the new coordinates. So I've given you a blank graph so that this is super easy to see. The new coordinates would be considering this as the y-axis and this as the x-axis. So when we spin back, right, that's the opposite of what they really are, but when we spin 90 degrees clockwise, this becomes my new y-axis, and all of this is positive and all of this is negative, and this becomes my new x-axis where all of this is positive and all of this is negative. So when I read T, I'm going to read that as -1, 1. G would be -1, 3. And B would be 1, 2, 3, 4, 5, -5, +3. My third is to spin the paper back and plot the vertex plot the vertex with the new coordinates that we found. So now I'm going to spin my paper right back the way it was, and I'm going to use these coordinates to plot my new figure. So this becomes my y-axis, this becomes my x-axis. I'm going to plot these 3 points. So -1, 1 is here, so that would be T prime. -1, 3 is here, and that becomes G prime. B5, +3, so that becomes B prime. And then lastly, I connect each point. And that is how you rotate 90 degrees. Now I'm going to do another example for a rotation of 180 degrees. You'll notice that I did not put clockwise or counterclockwise because if I rotated this twice, because 180 degrees is 2 quadrants movement, so that means I would go like this and then again like this, where this becomes my new y-axis and this becomes my new x-axis. So that's a rotation clockwise. So now let's rotate it the opposite way, counterclockwise. 1, see, we land in the same exact place, right? This is my y-axis, this is my x-axis. 180 degrees, clockwise or counterclockwise, puts you in the exact same position. So you don't have to worry about which direction. You'll always end up in the same place. So now I'm going to find my coordinates. So this would be +1, 1. This would be +3, 1. And then this would be 1, 2, 3, 3, 5. So now I'm going to spin my paper right back up. and I'm going to plot these points. So 1, 1 is here, and that's T prime. 3, 1 is here, and that's G prime. And 3, 5 is here, and that's B prime. Finally, I connect my points, and you'll see that we rotated our finger 180 degrees around the origin.